Hello, dear students. Welcome to our institute. I am Dr. R.K. Saini, and today I am going to discuss one more question of organic chemistry related to the isomerism. To explain isomerism, chiral center, etc., we taken an example of molecular formula C4H11N. In this formula, we find degree of unsaturation or double bond equivalent, then the double bond equivalent are 0. It means it is a saturated amine. Saturated amines. Their general formula CnH2n plus 3n. When n equals to 4, then this molecular formula fit in this. It means no double bond. Means it is a saturated amines. And we write many structures. First we write structures, then predict stereoisomers. Therefore, we write 4 structures of primary amine, namely N-butylamine. Second one is secondary butylamine. Third one is isobutylamine. And fourth one is tertiary butylamine. All 4 amines are primary because their functional group is NH2. These 4 amines, structural isomers, are primary amines. Their formula, the functional group in these isomers is NH2. And as these are the primary amines. Now, we write some structures of secondary amine also. In case of secondary amine, the functional group. In case of secondary amine, the functional group is NH. We write structure of 3 secondary amines, namely N-propyl methylamine, N-propyl methylamine, isopropyl methylamine, and third one is diethylamine. These are the secondary amine of this formula. And then we also write a tertiary amine. In functional group, in case of tertiary amine, is N. And their all 3 valencies are satisfied by carbon, or we can say alkyl group. Only one structure of tertiary amine is possible of this formula. Therefore, one is tertiary amine. Now, we consider total chiral center. Chiral center is a atom like as carbon at which 4 valencies. All 4 valencies are satisfied with different atom or group. For example, in case of primary amine, the secondary butyl amine contain chiral center carbon 1. Now, if all 3 valencies have satisfied with different atom or group, then lone pair of nitrogen, and this structure is also considered as a chiral. Therefore, this amines is also a chiral, but such type chiral carbon are rapidly, chiral nitrogen are rapidly interconvertible to each other, or flipping is there, and hence the molecules are non-resolvable. It means the D and L form cannot be separated from their mixture, or we can say we consider only one stereoisomers of molecular formula of CH2 or secondary amine of this formula. Consider only one, because flipping it takes place. However, we consider chiral center. Similarly, this nitrogen is also a chiral. This nitrogen is also a chiral because one is methyl, one is hydrogen, and another is isopropyl. And we know that all three valencies satisfied with different atom or group, then nitrogen is also a chiral. Therefore, three chiral center total. One chiral center is amine, and this chiral center is real chiral center, and their isomers, namely dextro and levorotatory, are separable because chiral center is a carbon in which no inversion or all valencies are satisfied with different atom, and hence total 5 primary amines, 4 structure, and in case of second we consider 2, namely D and L. 3 secondary amine, and 1 is tertiary amine, and hence total 9 isomers including stereoisomers, in which 8 are structural and 1 compound is optically active, and we consider there 2 stereoisomers, and hence total 9 isomers are possible. Again, we also discuss chiral center of nitrogen in which all three valencies satisfied with different atom or group. For example, in case of N-propyl, methyl, hydrogen, different atom or group as well as lone pair of nitrogen, then it is also known as chiral center. But due to flipping or rapid interconversion, like as umbrella, these molecules or isomers are non-resolvable. It means we cannot be separated, or we can say we consider only one isomer. Therefore, total 9 isomers are there. 5 primary, 3 secondary, and 1 is tertiary. Okay? And this is the question from isomerism. In another class, we also discuss some another question by important phenomena by which you improve their organic chemistry. Thank you.